I hope you are ready for today's lesson. Okay. So the focus of today's lesson is to discuss the various reactions that alkanes can undergo. But we should keep this in mind that alkanes are quite unreactive. Under normal circumstances, alkanes wouldn't like to react with any other atom or compound. Under normal circumstances, they would like to be on their own, to chill somewhere in their quiet corner instead of what? Having anything to do with other compounds. But the reason alkanes are quite unreactive is that they are saturated molecules. So we've gotten our first key term, that is saturated molecule. What does that mean? The alkanes are saturated. What does that mean?
It means that there's no space for bonding
There's no
in any way. No space for bonding.
Okay. So alkanes, let's keep that in mind. Alkanes are what? Saturated. Alkanes are saturated molecules. That is why they are quite unreactive. And if you pay close attention, we say they are saturated because there are no other species for bonding. So let's pick an example. Ethane. So ethane, that is this. So ethane is a 2-carbon alkane. So it has 2 carbons and how many hydrogens?
6.
6 hydrogens. 1, 2, 3, 4, 5, 6. And one interesting thing you will see about the alkane is that this ethane is, we have only single bonds, single carbon-carbon bonds. Look at this carbon. There is 1 carbon here, another carbon here. Look at the type of bond here. It is a single bond. And if you check through it, the remaining bonds are also what? Single bonds. It's because of this we say alkanes are what? Saturated hydrocarbons. Meaning, we can compare alkanes to those kids that maybe during school, they had their fill during lunch. Maybe their favorite food that we served, rice with stew and chicken. So they ate till they got very, very full or filled. So in that way, they do not have space for extra food. Even if you bring more lunch or more food, they might not be able to eat it. That's how alkanes behave. They have more than they need. So if you look at this, only single bonds. And this is completely different from alkenes. Let's pick an ethane, for example. For alkene, we have something like this. Do you see that?
Yes, please.
What's the difference between this and this? What's the difference?
There is a double bond between the carbons, and there are 2 less hydrogens.
Good. Look at this. This carbon 1 and carbon 2. There is a what?
Double bond.
There is a double bond. So because of this double bond, this double bond, we say this is what? An unsaturated. And because alkenes are unsaturated, they are really ready to undergo every type of what? Other type of chemical reaction. They are very, very sociable. Or in other words, they are those kids that didn't eat to their food. So they have more space to take in more food. That's how alkenes behave. So what is the point so far? Alkenes are quite unreactive. And one of the reasons is they are saturated molecules. Remember, we use a certain term. Alkenes are quite unreactive, meaning they can undergo some kind of reactions under specific conditions, but most of the time they would like to be on their own. And because alkenes are quite unreactive, there's a type of reaction called addition reaction that they do not like to undergo. Addition reaction. You see, in mathematics, when we say addition, what it basically means is that we have to add an extra substance to what we already have. Is that not so? I hope that's clear. Good. So for addition reaction, that means the substance, specifically the organic molecule, has to take an extra atom. But alkanes have no space for addition reaction. So the question is, what type of reaction can alkanes undergo? What type of reactions can alkanes undergo? Do you have any idea?
No, not
You
yet.
have no idea. Not yet. Hopefully, by the end of the lesson, you get to know the type of reaction that alkanes can undergo. And the first kind of reaction alkane can undergo is combustion reaction. So you can write that. Combustion reaction. They can undergo combustion. Let me write that on the board. So alkanes undergo combustion reaction. What does that mean? Another term for combustion is burning. Burning. That's one easy way to remember that, burning. So what is combustion? What's the meaning of combustion? Or when you hear burning, how do you understand burning? What is burning? Don't worry too much about the chemistry jargons or chemistry stuff. When you hear burning, I'm going to burn a rubber or a paper. Well, how do you understand that?
When something is under a flame and the flame engulfs it.
When something is under what?
A flame.
A flame, and the flame engulfs it.
Yes.
Okay, so will a substance burn in the presence of oxygen or carbon dioxide?
Oxygen.
Oxygen. So for burning to occur, we definitely need what?
Oxygen.
We definitely need oxygen. So this is what combustion means. Combustion is a chemical reaction between a substance and oxygen that releases energy in the form of heat and light. That's basically what combustion is. It's a chemical reaction between a substance and oxygen that releases what? Energy in the form of heat and light. So when we are talking about combustion of alkanes, what it basically means is that alkane will burn in oxygen. Alkane will burn oxygen. And the end result is heat to be produced. Carbon dioxide to be generated. Are you aware burning produces carbon dioxide?
Yes.
Good. So that's what happens when it comes to combustion of alkane. And there is a general chemical reaction for combustion of alkane. So let's have a look at it. Let's first look at the word equation for combustion of alkane. So what do you see? The word equation of combustion.
Alkane.
Alkanes plus
Oxygen.
oxygen going into
Carbon dioxide.
carbon dioxide
Water.
plus water. So
Yes.
that's the word equation for alkane that we have. So write that whilst we look at how to write the actual chemical reaction and more importantly, how to balance it.
Yes.
Before we move on with the actual chemical reaction of combustion reaction, I want to stress one more point. That is the kind of bond found in what? Alkanes. We'll use methane to explain that. In methane, do we have double or single bonds? We have only
Single.
what? Single bonds, right? And single bonds are much more stronger than what? Double bonds. So the bond between carbon and the hydrogen atoms are quite strong. And they are okay, saturated. They do not want to be broken. But under specific conditions, alkanes can undergo combustion reaction, meaning these bonds can be broken during the combustion reaction. When these bonds are broken, it generates large amount of heat. Exactly. It generates large amount of heat, and this heat is what we use. That is why alkanes like methane and co are used as fuels. That is why there is as what? As fuels. Now let's look at actual chemical equations of combustion. Remember we said the word equation is alkane plus oxygen going into what? Carbon dioxide plus
Water.
So we are going to look at actual alkanes and look at how to balance them. So our first alkane that we'll be picking is what? Methane. Easy, right?
Yes.
So methane plus oxygen will form what?
Carbon dioxide and water.
Carbon dioxide and water. Is this equation balanced?
Yes.
You think so? Okay, let's check if it is balanced or not. How many carbons do we have here?
One.
One. How many do we have here?
One.
So the carbon is fine.
Yes.
Hydrogen.
4.
How many do we have here?
2.
Is it balanced?
No.
No way, it's not balanced. So this chemical equation is not balanced. But here's the good news. There's a trick for balancing this kind of combustion reactions. I hope you want to know that.
Yes.
So here's the trick. You will check the subscript for the carbon in the alkene and just write that same subscript behind the carbon dioxide. That's the first step. So what's the subscript here?
1.
1. Although it's not shown. So here is 1. So we write that 1 here. But the truth is, we don't have to write it. We can leave it as it is. So we have 1 here and 1 here, so it's balanced. The next step is to balance the water or the amount or number of hydrogen present. How many hydrogens do we have here?
4.
4. Now, you will pick the number of hydrogens and divide by 2 and put that value here. So 4 divided by 2 is what?
2.
2. Now let's check for the oxygen. How many do we have here?
2.
How many do we have here?
2. 1.
2 plus 1, 3.
Yes.
I think I'm missing something. Okay. I've seen the mistake. Let's continue. Now let's balance the oxygen. How many do we have here?
2.
And how many do we have? We have 2 here plus 1.
1.
Okay, I think there is something missing here. Here is carbon dioxide, not carbon monoxide. I hope that's clear.
Yes.
Good. So how many oxygens do you have? 2 plus 2
Yes.
is what?
4.
4. Now, here's what we are going to do. That 4, we divide it by 2. So 4 divided by 2. So it will be 4 divided by 2. You see?
Yes.
But 4 divided by 2 is what?
2.
Is 2. So this is a balanced chemical reaction of combustion of what? Methane.
Yes.
Now let's check. How many carbons do we have there?
1.
1.
1.
What about hydrogen? We
4.
have 4. 4.
4.
Oxygen. 4.
4. 4.
I hope that's clear.
Yes.
Let's pick our next example. Ethane. Ethane, what's the chemical formula? What's the formula
C2.
C2H6. So we said combustion reaction, it is an alkane plus what? Oxygen going into
Carbon dioxide and water.
Carbon dioxide and water. So that's what we have. So what do we do from here? You check. The first step is to check the number of carbons we have. Look, we have 2 carbons here. So we just pick these 2 and write it behind the carbon dioxide. That's our first step. Second step, you check the number of hydrogens. How many hydrogens do you have?
6.
So this 6 divided by 2.
Yes.
6 divided by 2 is 3. So write the 3 here. I hope that's clear.
Yes.
Now what we have to do now next is to balance the oxygen. So in order to balance the oxygen, we'll have to find the number of oxygens here and then divide it by 2. So oxygen, we have subscript 2.
Yes.
And there is 2 in front, so 2 times 2 is
4.
4. That 4 plus how many oxygen do we have here?
5.
Check oxygen. We have
3.
3. So 4 plus 3 is what?
7.
So remember, we will divide it by 2. So this is the balance equation for this combustion of methane.
Yes.
But in order not to leave it in this form, we can decide to multiply all of this equation by 2. So that we will take care of this subscript.
Yes.
So if you multiply everything by 2, it now gives us 2C2H6 plus 7O2 going into 4CO2 plus 6H2O. Do you get that?
Yes.
Okay, so there is an example for you to try. So we are moving on to butane. Let me clean this side of the note. So try that in how many minutes? I think 3 minutes is okay, right?
Yes.
3 minutes. So write a complete equation to represent the combustion of butane. So do that quick. So for butane, we have C4H10. C4H10 going plus oxygen going into what? Carbon dioxide plus
Water.
So now work this. Solve this, balance the equation. You have 3 minutes to do that. Start work. So, are you done?
Yes, sir.
You're done. So, what did you get? Well, actually tell me your answer. After that, we'll check it.
Okay.
So, what did you get?
4CO2.
Where? This side. Is there any number here?
No.
No. What
The
about
subscript.
this side?
On the other side.
Where? This?
Yes. 4CO.
4. Okay.
10H2O.
So, this side, you got 10.
And 7 on the oxygen.
This
Yes.
side.
Yes.
Okay. So, you got C4H10 7O2, 4CO2, and 10. Okay. Well, let's solve it and see. Okay, so let's see if you are right or wrong. But are you confident with your answer? Are you confident in your answer?
Yes.
You are confident in your answer?
Very much.
Very, very confident.
Yes.
Okay, let's see. I just hope you are right. I think our marker is disturbing us. C4H10 plus O2 going into CO2 plus H2. Okay. Decision time. So let's see. How many carbons we have here?
4.
4. So
Yes.
just pick this 4 and write it behind the carbon dioxide. So you have
Yeah.
4
CO2.
Excellent.
Excellent.
Now we have how many hydrogens we have here?
10.
10 hydrogens. So we divide that 10 by
2.
giving us 5. So write the 5 here. So that gives us 5H2O.
Yes.
Now we have to balance the number of oxygens. Let's check. How many oxygens do we have here?
4.
4 times 2, 8.
8.
Right? So this side we have 8. And here we have 5. Right?
Yes.
And 8 plus 5 gives us
13.
13. So remember, that value that we got, the 13 that we got, we have to divide the 13 by
2.
So 13 divided by 2. So the actual balanced chemical reaction for this equation will be C4H10 13/2O2 4CO2 plus 5H2O. But we do not want to leave it in this form. We want to do away with this 2. So what do? We multiply through by
2.
So we have, when multiplying through by 2, we have 2C4H10, I hope that's clear,
Yes.
plus 13O2 going into 8CO2 plus 10H2O as our final answer.
Yes.
So now, compared to your answer, why? Why? So are you correct? I have to complete your answer. Okay. I think that's clear, right? If you want to redeem yourself, then write a balanced chemical reaction like combustion reaction for pentane.
Why are you doing this to me?
Pentane.
Fine.
Let's see. Pentane.
Fine.
So write.
I'll do it.
Let's quick pentane. I just pray that you get that one correct. So you have 3 minutes. Pentane. Right now. Are you done?
Yes.
What did you get?
I'm done.
What did you get?
Please don't laugh at me.
Oh, why should I laugh at you? Hopefully you should get it correct. So
I
let's.
got 8O2
Where?
on the oxygen.
This?
Yes.
You got 8?
Yes.
Is that all?
Nope. I also got 5CO2.
5?
6HO2.
H2, right?
Yes, sorry, H2.
6. Really? I have a
Yes.
feeling it's wrong. I had a feeling it's wrong. Maybe my feeling is wrong.
That's what they all say. That's what they all say.
Not what.
That's what they all say.
Okay. So let's see. Let's see what it is. So I'll be rewriting this equation C5H12 plus oxygen. I hope it's clear. Can you see?
Of course. Can see perfectly. Just fine.
Okay. Now step number one. Step number one. Check the number of carbons. How many carbons do we have here?
5.
5. So you write it here.
Yes.
Okay. You're on track. How many oxygens do we have here?
12.
12, right?
Yes.
Divide by
2.
2. So 12 divided by 2.
Why are you laughing?
You are really on track. Now let's check. 2 times 5
10.
times 2, 10 plus 6.
16.
16 divided by 2.
8.
8.
Finally.
Finally.
Yes.
You've redeemed yourself.
Yes. Let's go.
Now that makes you happy, right?
Yes.
You feel happy?
Yes. I'm going to jump out the window.
You are going to do it.
Going to jump out the window.
So you are really right. So let's recap
go.
the steps. Whenever you have a combustion reaction to balance, the first step. Can you tell me the first step?
Take the subscript of the carbon and move it to the other side.
Subscript of the
Carbon. Yes.
in the alkane.
Yes.
And put it where?
In the reaction of CO2.
Okay, this compound. Then what's the next step?
Take the subscript of hydrogen and divide it by 2.
And place it where?
On the H2O.
H2O. Is that all?
Nope. You have to multiply the number of carbons by 2. Then we add it to the...
Do you mean balancing the oxygen?
Yes.
So for that, we find the number of oxygen at the product side.
Yes.
And divide by what?
2.
2 and place it here.
Yes.
So these are the simple steps. No matter the reaction you are giving, no matter the alkane. Exactly.
Yes.
So we are concluding our lesson on combustion reaction. In our next lesson, we'll be looking at substitution reaction. So you can take note of that. In our next lesson, we'll be looking at substitution reaction. But before we conclude, there is one thing I want to mention. That is, what we are looking at so far is known as complete combustion.
Yes.
It's known as what? Complete combustion. That means that the alkane is burning in sufficient amount of oxygen.
Yes.
There are situations where the alkane might not have sufficient amount of oxygen. So the end product will not be carbon dioxide, it will be carbon monoxide. In that situation, what it basically means is that the amount of oxygen needed to completely burn the alkane is not enough. So instead of producing carbon dioxide, you end up producing what? Carbon monoxide. But do you think producing carbon monoxide is dangerous?
I don't know, maybe.
Maybe. It's really dangerous because carbon monoxide is odorless, colorless. And then when it gets into our system, it will bind with our hemoglobin.
Oh no.
You remember our hemoglobin needs to bind with oxygen.
Yes.
And then transport the oxygen to every part of our body.
Yes.
But carbon monoxide binds better than oxygen does.
Does that make any sense?
How
does that make any sense?
How does that make any sense?
Yes.
Well, that's nature for you. So, surprisingly, carbon monoxide binds better to hemoglobin more than oxygen does. So now imagine yourselves transporting carbon monoxide instead of what? Instead of oxygen. It can be very, very fatal. And interestingly enough, most of the pollution we have around is as a result of what? Incomplete combustion of alkanes. So in our next lesson, we'll be looking at the other reaction that alkanes can undergo, that is substitution reaction. So go over this note, get used to the content of the note, and read on substitution reaction before our next lesson. Okay, so see you there.
Bye-bye.